Good morning. My name is Mat Kamel. I will be the last presenter for this conference. Um, I will be presenting a paper entitled Class 1 and Class 2 Underwater Image Enhancement and Restoration under Turbidity Condition. The authors are myself, Halimatun Saida Aminuddin, Nurul Kamil Ahmad Kamil, and Kamarul Lashikin Mustafa. My presentation outline, introduction, a bit of literature review, um, methodology, result and analysis, conclusion and future works, references, and we have question and answer at the end of the presentation. The introduction, pre-processing is an important step in image processing techniques. This technique is to correct, in this case is the underwater images due to the water turbidity so that the images can be processed for the purpose of navigation underwater. In this paper, we are not going to present the navigation part of it. And that is the ongoing research currently. The pre-processing step, which is considered in this paper, are the image enhancement and image restoration. Turbidity condition. Turbidity is the measure of the clarity of the liquid, which is in the unit of NTU. The turbidity is caused by particles suspended or dissolved in water that scattered light, making the water appear cloudy or murky. The high turbidity can significantly reduce the aesthetic quality of the water, and the visibility is highly impacted by the level of this turbidity. Hence, the quality of images are compromised. The objective of this research is to develop and optimize enhancement and restoration techniques for underwater image in turbidity condition. And the turbidity condition which is considered in this research is the milky degradation, chlorophyll degradation, and bluish water condition. Um, we are trying to incorporate the image enhancement techniques, various histogram equalization together with the Wiener estimation filter classes. We also to analyze these different classes of the Wiener filter with the various combination in terms of the order of the enhancement and restoration. And we do this and compare according to the quantitative measures and also qualitative measures. The ultimate objective of this project is really to develop a real-time algorithm for automated underwater vehicle. Okay, now we go into a bit of literature review in terms of the image enhancement. The process of image being manipulated to improve the appearance of the image through the enhancement technique. Image enhancement, we do image enhancement due to there is no prior information on the degradation model of the corrupted image. So therefore, we will not be able to do the quantitative evaluation. So we can only do the qualitative evaluation. So it's more focused on the improve the image and produce a good result based on the qualitative measures. Normally that we work with histogram equalization, we'll work with the probability density function and cumulative distribution function, the density function. Yeah. Um, Low intensity value will become slower and high intensity values will become higher and cause the output image to produce under and over saturated areas. Yeah. Um, this is the global histogram equation, where first we do the probability density function, then we do the cumulative density function, and then we calculate for the new value and construct the image by replacing the pixel value with a new value. The other variation of the histogram equalization, basically the cumulative histogram equalization, quadratic dynamic histogram equalization, AHE and CLAHE. This variation of histogram equalization basically that to take into consideration of the non-uniform distribution, the density distribution. the probability density distribution in the image. And we also have to take into consideration of the complexity of the calculation of in order for us to implement real time. So for this project, we take the simplest one so that we try to minimize to simplify the calculation. Right? For the image restoration, the process of improve the quality of the corrupted image by manipulating the prior knowledge or the a priori of the images, because the the degradation model is known in the image restoration. So the method of image restoration can be filtering, such as averaging, median, smoothing, or estimation. In this paper, we are using the Wiener filter, since it's a ID low pass and non-linear filter that uses the least squares to reduce the error. The strength of the Wiener filter is the simultaneously eliminates or reduce the blur and noise in the image. These are the Wiener filter classes. The class 1 filter, the equation that's given for class 1 filter, basically that we have the a priori knowledge of the signal and the image properties, the statistical properties such as means of the signals. For the class 2, we only know the signals statistical properties, whereas for the noise, we need to estimate from the corrupted images or corrupted noise. Corrupted signals. For the class 2, which is not in this paper, is when this is actually the most practical in the real world, where you have where you have no knowledge of the actual signals or actual noise statistical properties. So both must be estimated from the input signal. The methodology, as shown in the diagram, where we input the image, and then after that we look at whether the degradation model is available or not. If it's available, then we do the image restoration. If not, then we do the image enhancement. Whereas for the hybrid, we don't really care whether the model is available or not in this case. So that is what we are going to do after this. And after that, we do the qualitative measure and we do the analysis of the dataset use is a TURBID dataset, which consists of the collection of 5 different subsets of degraded images with its respective ground truth. The subset that we use, milk, blue, and also chlorophyll. So we have 20 images in each set, except for the chlorophyll, which is 42 images. These are the qualitative measures. This is MSE, PSNR, and SNR. This is the results. The one that is in the paper is which is in the red box. We use the 50 milliliter degradation. Actually, we do for 20, 50, and 160, but in the paper we only shown the 50. From this result, we see that the image enhancement using the histogram is quite improved. Same thing with the chlorophyll. Same thing with the bluish water. Okay. And for the image restoration, using the Wiener filter, for the qualitative measures, we can see that for Wiener filter class 1 and Wiener filter class 2, you can see some improvement in the clarity of the images. Class 1 and class 2, basically that based on the viewing of the image, we don't see much difference. But when you look at these the quantitative measures, we see that class 1 has a better performance. And of course, this is actually in accordance to the theory, where since the images, for class 1, we know the statistical properties of the signals and also the noise order, the image, and also the corrupted the noise that corrupted the image. Yeah. Same thing with the chlorophyll water. The same observation that we can see, and based on the quantitative measure, also the class 1 has performed better. Same, the bluish, similar, and measures also class 1 is better. And now we go into the hybrid, where we don't check whether we have the information or not, and that we go into the enhancement and restoration combination. First, we look at the restoration, where we go through the filtering, the estimation filter first, then after that we go into the enhancement. These are the output from the simulation that we have done for the all the three types of the degradation, and also for the two filter, class 1 and class 2. From the output, basically that class 1 and class 2 has not much different. This is the qualitative measures also, but this is for the hybrid wedge, which we do the enhancement first. Basically, we do the the histogram equalization, and we restore using the Wiener estimation filter, class 1 and class 2. These are the comparison of the three method, which is the first one. We use a Wiener filter without any enhancement. The second one is the hybrid of restoration and enhancement. And the third one is the enhancement then restore. Based on the quantitative measures, we can see that for the class 1 and class 2, the Wiener filter without any enhancement performs almost similar to the if we do the enhancement then restoration. Yeah? So, and also we can see that class 1 filter perform as expected, which is better than the class 2 filter, because the class 1 we have the knowledge of the statistical properties of the signals and the noise. So this actually observed in all the three types of the degradation, the turbidity condition. Okay. So in conclusion, the histogram equalization and Wiener filter is proved successful to enhance and restore the underwater image and to get the desired visibility. This project also achieved the most important objective, which is the project wants to combine these two enhancement and restore technique in single output, which given low value of mean square error and high in the PSNR and SNR. And of course, we can look into the future to enhance the technique for histogram equalization, such as the AHE and CLAHE. But we need to keep in mind of the trade-off of the simplicity and accuracy, consideration for real-time implementation, and of course, further improvement for practical application is to use the Wiener filter class 3, which could be explored. These are the partial list of references, and I end my presentation with the question and answer session. Thank you.